Okay, so this is examples from 13.6. So we learned that back in the other notes that we took, back here, that when we have a point, cosine is the x, sine is the y. And that should be something that's becoming more familiar to us. So when it says to find the cosine and the sine of these angles theta, then, and we give us a point, well, it's pretty easy just to say, well, cosine is the x, the x value, and sine is the y value. And that's all that there is to those. So let's go on just a little bit more. Some other terminology, other than just knowing the x and the y points, is the new word period. So if we go back and look at what our definition for that was, a period is the repeats at regular intervals. It completes a pattern of which is considered one cycle. So the horizontal length of one cycle is a period. So when does it start? When does it complete its cycle, or when does it start repeating? All right, so if we start at 0, 0, it goes up and over and up and keeps going. Now, when does it actually repeat? It gets back to the starting point and repeats the entire pattern right there. So that I could take this and drag it over and it matches. Oops, I have to group that now again. There, it matches. Or I could slide it here and it would match. Some people get confused and they think that this would be a period because that's when it gets back to 0. But if I slide it over the end point to the starting point, it doesn't match up there. So that's why this one is, I gotta group it again. If this is my end point, and I move my starting point to my end point, then it matches up. So that right there is the length of the period, so it would be at pi over 3. That's the length of my period. All right, let's make a table for a bicycle wheel. So take a second to read through this problem. And you might hit pause to do that. Okay, now if you actually look at this wheel, there's a mistake on it because if you're going this direction, and you'd be here in 0.5 seconds, and then you'd go down and you'd be there at 1, and up here you'd be at 1.5. So there's a misprint. They got those two numbers mixed around. Okay, well, and then we get back to the top at 2. Well, where would we be at 3 seconds? Well, we'd go around once is 2 seconds, and we need one more, so we'd end up being down here. Well, how high is that? That would be a height of 4. Okay, then at 3.5, that would end up being over here again. Well, that's up to 11. 4, it's up to the top again. That's 18. 4.5, back to this spot right here. So that's 11. 5, now we're down at the bottom. 4. So that's the height of it. Identify the period. So when does it start repeating? When do you get back to the original spot and redo the exact same thing? Well, that would be after 2 seconds. So that would be our period. Let's graph it. So at the beginning, how high is it? It's at 18. So we'd start up here at 18. Oh, about right there. And then remember these are switched up, so let me rewrite those. That's 1.5 and that's 0.5. At 0.5, it would be at 11. At 1, it's going to be at the bottom, which is at 4. At 1.5, it's back up to 11. And 2 up to 18. Okay, so then at 2.5, back to 11. And then down to 4, back up to 11, back up to 18. And this pattern just keeps going on forever. Now, this is not a jaggedy graph, it's a smooth graph. So we'd start like this and like that. You have to smooth it out, not go V-shaped graphs. And like that. And there's our graph. Okay, so now when we're working with this, though, we need to make sure that we're really good at finding the exact value of things like this. So we're reviewing this even though we did this earlier. Cosine of 690. First of all, we got to find our reference angle. So if we go around once, we went around 360. If we go around twice, we're at 720. So that's too far. We couldn't have gone that far. How much short do we have to go from that? Well, we should have been about 30 degrees shy of that. So let me go back. And here. So our reference angle, connect it to the closest x-axis and 30 degrees shy of that. So how do you find the exact value of cosine? It's the square root of something over 2. So cosine was 4, 3, 2, 1, 0. So 4 was for 0 degrees, 3 is for 30, 45 is 2, 60 is 1, 90 is 0. So we're looking at a 30-degree angle here, so we take the 30, which is over there. It's the square root of 3 over 2. Now double check if it's positive or negative. All students take calculus. Here, cosine is only one that's positive. We are doing cosine, so it is a positive number. All right, let's do it in radians then. So we have sine of negative 3/4 pi. Okay, remember you can always change this to degrees, but we really want to be working on keeping it in radians. So let's think about this. If we went 180, it would be 1 pi. 3/4 is not quite 1. It's about a fourth short. So again, this it would be negative 1 pi. But we don't want that. We want to be a little short of that. We want to go 3/4 of the way there. And so how much is left over? 1/4 pi, or we could write it as pi over 4, because we don't really need that 1 up there. So pi over 4 is our reference angle. Well, what is pi over 4? Well, it's half of 90 degrees, so it's going to be 45 degrees. So let's draw it out. Sine went from 0 to 4 over 2, 45 degrees, 0, 30, 45, 60, 90. There's 45 degrees. Square root of 2 over 2. Is it positive or negative? All students take calculus. Tangent is the only one that's positive, meaning sine must be negative. So there's our answer for that one. Okay, that concludes lesson 13.6, and you can write your questions and your summaries.